Okay, hi, welcome back. Oh my gosh, already test 3. Yeah, so test 3 review. This time, it'll be one of our written out tests. You'll take it in WebEx. I'll be proctoring, and you'll have to print out my test. You'll have to take pictures, upload it, and you could convert to PDFs just by taking pictures, upload it to your computer, and then put the pictures into Microsoft Word document. And then when you go to save the document, it has Save As button. You just toggle down the Save As button, and it should have a PDF option, and you just save it as a PDF, and then you don't need to use the CAM scanner app if you don't have to pay for it and stuff. Okay, so if you don't have the money clearly and you're not interested in investing and converting to PDFs, you can always use Microsoft Word to kind of backdoor that issue. Okay, so anyways, there's that. This will be a lot like test 1 in its format. So when you study here and you are watching my video, what you want to do is watch me do this problem and then pause the video and find a problem like it in the book. For example, the first problem I'm going to do, number 15, you probably want to go in the book and look at number 12, number 13, one of those, 16, and try that. Okay, so this first kind of problem, I want you to graph by making a table of values. Okay, so I'll probably on the test tell you those values. If I don't, just use -2, -1, 0, 1, 2. And all we're doing here is plugging these values into that formula. So you'll have 1/2 to the -2, which is the same as 2 to the 2, which is then the same as 4. Okay. 1/2 to the -1 is the same as 2 to the +1, which is 2. Anything to the 0 power except 0 is 1. And then 1/2 to the first power, of course, that's just 1/2. And then 1/2 squared is 1/2 times 1/2, which is 1/4. Okay, and then you'll go over to your XY plane. Okay, and then you'll graph the thing. 2, 3, 4. So at -2, it's 4. -1, it's 2. 0, it's 1. 1, it's about 1/2. And then 2, it goes to 1/4. Okay. And then you'll graph it, and there it is. Okay, let's see. Begin by graphing f of x equals 2 to the x, then use transformations to graph the given function. Make sure to note the asymptotes and the domain and the range. Okay, so this is problem 29. And we want to graph h of x equals 2 to the x plus 1 minus 1. And these kind of problems, I'm not going to be doing the vertical or horizontal stretches. So no vertical or horizontal stretches or shrinks. Okay, I'm only going to be doing vertical shifts, horizontal shifts, and rotations. Okay, so the first thing the instructions tell you to do is to graph f of x equals 2 to the x. Okay, so we do a little table just like we did above if you need to. So -2, 2 to the -2 is 1 all over 2 to the +2, which is 1 over 4. -1, 2 to the -1 is 1 all over 2 to the +1, which is 1 over 2. 0 is, of course, 1, and then 1. 2 to the 1 is 2. 2 to the 2 is 4. Okay, so we begin by graphing that critter, and then we're going to use translations to get our new graph. Okay, so -1, 2, 1, 2, 3, 4, 1, 2, 1, 2. So negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2. Make sure you're reading the directions so you give all the information I asked for. So 1, 2, 4. Okay, so here's our original graph. And it has an asymptote on the y-axis. Okay, so in this problem, you want to make sure that you're labeling asymptotes. And you have to do this in the software as well. So, okay. All right. So then you have to do the horizontal shifts first. So we have a shift to the left by 1. Okay. That's the x plus 1 in the exponent. So shift left 1. And then the minus 1 there will move it down 1. Shift down 1. Okay. All right. So let's put this maybe in blue. So I go left 1 and then down 1. So I take this point, I go left 1 and then down 1. Left 1, down 1. Left 1, down 1. Left 1, down 1. Left 1, down 1. Okay. The horizontal asymptote will go down by 1, so it will now be sitting right here. And let's connect the dots for our graph, our new graph. Look like that. Okay. And then we want the domain and range of the new guy. So the domain is always going to be negative infinity to infinity. So the domain of, I'll just say h. And then the range of h will go from, in this case, negative 1, that's where the asymptote is, to infinity. Okay, so some graphing problems from 3.1. Now moving on to 3.2. We have problems similar 1 to 45 odd, and then 75 to 79 odd, and then 81 to 99 odd. And what this, so we're dealing with logarithms now. Can you evaluate logarithms? Can you convert from exponential to logarithmic form? And then can you graph them and determine domain of logarithms as well? So there's a lot in 3.2 to worry about. The first type we'll say going from log to exponential form. So something like number 5, we have 5 equals log base b, as in boy, of 32. So to convert this to log, it'll go, you start with the base, right? Here's your base, b to the 5th power equals 32. And that's how you rewrite it. So b to the 5th power equals 32. Okay. Now in the other direction, going from exponential to log, we want to be able to do that as well. Okay, so here we have the cube root of 8 equals 2. You may want to rewrite this as 8 to the 1/3 power equals 2. Okay. So this time the base is 8. Okay, and then it's 8 to the 1/3 power goes on the other side equals 2. Okay, so you have to be able to rewrite that, and that may take a little bit of practice. Okay, we'll also expect you to be able to evaluate these things without a calculator. You should be able to do these in your head. So 31 log base 2 of 1 all over root 2. So these are the problems you're asking yourself. 2 to what power equals 1 over root 2? Okay, and you could write 1 over root 2 as 1 over 2 to the 1/2, which is 2 to the negative 1/2. So 2 to the negative 1/2 power equals 1 over root 2. Okay, 33 log base 64 of 8. So 64 to what power equals 8? It's a square root, right? So it's a 1/2 power. 37 log base 4 of 1. Everyone should know that. 4 to what power is 1? 0. 39 log base 5 of 5 to the 7. 5 to what power is 5 to the 7? Well, clearly that's 7. You have to know how to graph these things. So to graph these things, you basically graph its inverse, and then go ahead and rotate it about the line y equals x, or you can just flip-flop the coordinates, right? So problem 45, we want to graph f of x equals 1/2 to the x power, and g of x equals log base 1/2 of x. Okay, so what I'll do is graph or get tables. I like to do tables. So f of x equals 1/2 to the x, and I'm going to go x, y, and just plot like -2, -1, 0, 1, 2. Right? So here will be 1/2 to the -2 is the same as 2 to the +2, which is 4. 1/2 to the -1 is the same as 2 to the +1, which is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. And then 1/2 to the 2 is 1/2 times 1/2, which is 1/4. Okay, so to get the graph of the log version, which is the inverse, log base 1/2 of x, one way you can do it is just by swapping the coordinates. So you can go 4, -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2, and that'll work. Okay, so let's go ahead and try that. Looks like we need about 4 tick marks on each axis. I'll do 1/2 x in blue. So -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. Okay, so there's my f of x. You should probably label it if you don't have nice colors like me. So f of x. Let's do g of x in red. So 4, -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2. Okay, so that guy will look like this. And there's our g of x. Okay. Okay. Find the domains. So recall finding the domain of a logarithm. If you have a log base b of some function of x, we'll say u of x, we require for the domain that the insides of the logarithm are greater than 0. Okay. So for a problem like number 77, we want to find the domain and express it in interval notation. What you do is basically just borrow the insides of the logarithm and form this inequality and then solve the inequality. Okay, so add x to both sides, you'll get x less than 2. Okay, and that's the domain. The domain is a set of all real numbers such that all real numbers x, such that x is less than 2. Okay, so you have to write it in interval notation, and there we go. More evaluations without a calculator. Evaluate the log. So these is common log and natural log. So remember the common log, log of x is log base 10. And then the natural log is log base e. Okay. So here we go. Log of 1,000 is asking 10 to what power equals 1,000. 10 to what power equals 1,000. Basically just count the number of zeros. That would be 3. Number 90, the ln of e to the 7. Okay, so this one's asking e to what power equals e to the 7th, and that's just going to be 7. One more. E to the ln of 300. Here the e and the ln are inverses of each other, so those will cancel. And you'll just end up with a 300. Okay, so that's some of our laws. Basically, e to the ln of x is equal to x, and the ln of e to the x is also equal to x. Okay, 3.3 then gets into expanding logs and condensing logs using the properties of logs. I'll be looking at problems like 1 to 69 odd. So, first dealing with expanding. You'll be given some sort of logarithm and you want to write it as a sum or product, a sum or difference of logs. Okay, so here we have log base 6 of 36 all over the square root of x plus 1. So the first thing I can do is the quotient rule for logs. So the quotient is the difference of logs. Make sure you simplify any logs that you can. So this guy you can simplify, right? It's asking 6 to what power equals 36, and that would just equal 2. The other log isn't done either. They want you to get rid of any exponents inside the log. So here it's really an exponent of 1/2. So you could take the 1/2 and put it in front using the power rule of logarithms. Okay. And then that would be done. Okay. There's just a whole bunch of these for you to practice in the book. Almost like a hard one. So here's log base b, as in boy, of the cube root of x times y to the 4th all over z to the 5th. Okay. So the first thing I'm going to do is the quotient rule again. I have log base b of the cube root of x times y to the 4th minus log base b of z to the 5th. Okay, and all of this stuff is in that first log. So that would be log base b. Now I'm going to use the product rule, right? And I'm going to rewrite, also on top of that, I'm going to rewrite the cube root of x as x to the 1/3. Okay, plus log base b of y to the 4th minus log base b of z to the 5th. Now I'm going to use the power rule. So it'll be 1/3 log base b of x plus 4 log base b of y minus 5 log base b of z. Okay, and then that'd be it. Okay, so there'll be those expanding formulas and then going in reverse, right? So then there's going to be the condensing formulas. So, for example, 59, they'll start you off with a bunch of logs, and you have to turn that into one log without a coefficient, so without anything in front of it. Okay. So before you can do the quotient rule, you have to do the power rule. So in that last problem, the last step we did was the power rule. Now it's like reverse. Now the first step you do has to be the power rule. Okay, so we'll have ln of x plus 6 to the 4th power minus ln of x cubed, and then I can do the quotient rule. So this would be the ln of x plus 6 to the 4th all over x cubed, and then you're done. Okay. So you don't want anything in front of that logarithm. Let's try another one, a harder one, 67, 1/3 times 2 ln of x plus 5 minus ln x minus ln of x squared minus 4. Okay, so there's more than one way to do this one. The way I usually do it is to do the stuff inside parentheses first, just like order of operations. So inside the parentheses, I can do a power rule. I got to do a power rule first on that first guy, ln of x plus 5 squared minus, and I just do one thing at a time, minus ln of x squared minus 4. I can combine the first two using the quotient rule. So ln of x plus 5 squared all over x minus ln of x squared minus 4. Okay. And then I can use another quotient rule, and I'll have 1/3 ln of x plus 5 squared all over x times x squared minus 4. And then finally do the power rule. So ln of x plus 5 squared all over x times x squared minus 4 raised to the 1/3 power, or the cube root power. Okay? If you'd rather, ln of the cube root of x plus 5 squared all over x times x squared minus 4. Okay, so the next section then, 3.4, is basically putting everything now that we know about exponentials and logarithms together to solve equations. So problems like 1 to 91 odd. Okay, so for exponential equations, there's two ways to do it. You can equate the base and then equate the exponents, or you can take the log on both sides. Okay, so first let's do the sort of equate the base type problem. And honestly, you could just take the log on both sides of these as well, but let's just try to keep with the book. So I could turn both of the sides into base 2, right? 32 is the same as 2 to the 5th. And then 8 is the same as 2 cubed. Okay. 2 to the 5th raised to the x, you multiply exponents in those cases. And then finally, we can equate the exponents. So 5x equals 3, and then x equals 3/5. Okay. Another one, 15, 6 to the x minus 3 over 4 equals square root of 6. So clearly, now we can get the base 6 on both sides. Just change the radical into an exponent, and then equate the exponents. You can cross multiply if you want. You'll end up with 2x minus 6 equals 4. So 2x will equal 10. So x will equal 5. Okay. Okay. Now moving on to ones where we can't get the same base on both sides. For example, e to the 1 minus 5x equals 793. Okay, so I can't get base e on both sides, so what you end up having to do then is the logarithm. So ln e to the 1 minus 5x equals ln of 793. The ln and e are opposites, inverses, so you'll end up with 1 minus 5x on the left, ln 793 on the right. Then you want to solve for x. Okay, so I'm going to move the 5x to the other side, and then subtract the ln from both sides. And then finally, I can divide by 5. Okay. On my test, I'll say leave your answer in terms of logs, or I'll want a decimal approximation. If I say leave your answer in terms of logs, you would stop at this point. If I want a decimal approximation, I would put in negative 1.14. Okay, and I can get that using my calculator. Let's try another one. Sorry, I'm just writing a note for myself. Somebody sent me an email. I forgot to email them back. I just remembered that email. So anyways, 5 to the 2x plus 3 equals 3 to the x minus 1. This kind of problem will definitely be on the test. You can't get the same base on both sides, so you got to take ln's. Okay. That will give you 2x plus 3 times the ln of 5. On the other side, you have x minus 1 times the ln of 3. That's just the power rule of logarithms. Then you have to distribute on both sides. Okay. Then collect all the x terms on one side. Factor out the x. Then you can divide both sides. And then you can put it into your calculator. There's other ways to simplify this, and this may look kind of crazy, but I don't think it'll kill us to look at it. So you can go ln of 5 to the negative third minus ln of 3 all over ln of 5 squared minus ln of 3, which will equal ln of 1 all over 5 cubed, which is 125, minus ln of 3 all over ln of 25 over 3, which will equal ln of 1 all over 3 times 125, 15, 6, 7, 375, all over the ln of 25 over 3. Okay, so that would be as simplified as you could really get it. But ultimately, you just want like a answer from your calculator. So let me just get that answer really quick. So I'm using ln of 1 divided by 375 divided by ln of 25 over 3. And that equals negative 2.795. So to 2 decimals, it would be approximately negative 2.80. Okay. Moving on to logarithm problems. The problem with logs is you must check the solutions. Okay, so for log equations, you must check solutions. If you don't, you're going to lose points. I will take off points. I don't care. No, I care, but you got to check your solutions. So anyways, let's look at 59. So log base, and again, there's 2 different ways to solve these things. You can use the definition, or you can use you can get logs on both sides and then equate the insides of the logs. So using the definition first, we have 4 to the third power equals 3x plus 2. So 4 to the third is 64. That equals 3x plus 2. Okay. And then solving for x, 3x equals 62, and then x equals 62 thirds. Okay, then we have to check the answer. And to check it, you have to put it into the original logarithm. Okay, and we're worried about having a result of a negative inside of a log, right? That's what we're watching out for. So anyways, 3 times 62 over 3 plus 2, we want that to be 3. It's log base 4 of 62 plus 2. The 3's cancel in this multiplication. Log base 4 of 64. 4 to what power equals 64? Well, that's 3. So this one works. So therefore, that is our solution. Okay. Next, so number 69. We have log base 3 of x plus 6 plus log base 3 of x plus 4 equals 1. Okay, so here I'm going to have to use the product rule in order to take advantage of the definition of the log. So I go log base 3 of x plus 6 times x plus 4 equals 1. And then using the definition, it's 3 to the first power equals x plus 6 times x plus 4. And then you just FOIL that guy on the right, and you're going to get a quadratic equation. So you got to set it equal to 0. And so I have x squared plus 10x plus 21 equals 0. And then factor it. X plus 7 and 3, right? 3 0. So we think our solutions are -7 and -3. Okay, but we got to check those. Okay, we have to check them in the original equation. Let's try -7. Okay, so we'll have log base 3 of -7 plus 6 plus log base 3 of -7 plus 4. Simplifying, we see, we can't have a negative result in a log. So as soon as you get a negative result like that, you're done. Okay, that will not work. No can do. And we have to throw out that solution. This guy doesn't work. Okay. Let's try the other one. It's -3. And notice this guy is negative, but it doesn't mean that the result inside the log will be negative. Okay. So you try it. Okay, so we got log base 3 of 3 plus log base 3 of 1. 3 to what power equals 3 for this first guy? That's just 1. 3 to what power equals 1 for the second guy? That's just 0. Okay. 1 plus 0 is 1. 1 is 1. So we're good there. So that one works. And our only solution is -3. Let's try one more. Okay. This is using the other method for solving logarithmic equations. So we'll basically get log on both sides, one log on both sides, and then equate the insides. Okay, so here we go. Log of, I use a quotient rule, so x plus 4 all over 2. 5x plus 1. And then you can literally just equate the insides of the logarithms. Okay. So you have x plus 4 over 2 equals 5x plus 1. Okay. Multiply both sides by 2, hate fractions, get rid of them. So x plus 4 is 10x plus 2. Collect all the x's on one side. 9x equals 2. So it looks like x is 9/2. Then we have to go back and check the thing. Or is it 2/9? That's what I get for going fast. Don't be like me. 2/9. Okay. Right. So we have log of 2/9 plus 4 minus log of 2 equals log of 5 times 2/9 plus 1. So that'd be log of 2/9 plus 36/9 minus log of 2 equals log of 10/9 plus 9/9. Then that would be log of 38/9 minus log of 2 equals log of 19/9. And then that would be log of 38/9 divided by 2, in other words, multiplied by 1/2. Equals log 19/9. 2 goes into 38 19 times. So it looks like we got it. Log of 19/9 on one side, log of 19/9 on the other. Those are the same. So we are good, and that is our solution. Okay. Okay. So the last section then was all about applications, mathematical modeling, basically. 19 to 31 odd will be the type of questions I'm looking at. So you should have this a equals a sub 0 e to the kt memorized. I'll probably give it to you, but don't count on it. E to the kt. And this is problem 31. So they're telling you the half-life of Xanax. The half-life of Xanax is 36 hours. Okay. How long until the Xanax in your system, so I suppose you took a pill or something, how long until the Xanax in your system decays to 90% of the original dose. Okay, so the half-life basically says, an ordered pair. It's an ordered pair, right? So 36 hours, 1/2 of the original amount will be left. Okay, and that'll allow us to solve out for k. So if you plug that into your formula, here we go. A equals a sub 0 e to the kt. So this is your t value, this is your a value in the ordered pair. It's always t comma a. Okay. So you'll have 1/2 a sub 0, 1/2 of the original amount is left over. We don't know what the original amount is, so we'll just say it's a sub 0. And then e to the k times t, and t is 36, so we'll write 36k. So even though you don't know a sub 0, you can get rid of it in this equation just by dividing both sides by it. And you're left with an equation in terms of one variable, so you can solve that for k. Right? So you just take the ln on both sides, and you get 36k equals ln of 1/2. And then you can solve for k, which is ln of 1/2 all over 36. So now our formula a equals a sub 0 e to the ln of 1/2 all over 36 times t. Okay, now we want to know how long until 90%, until it decays to 90% of the original dose. So 90% of, that word of means multiply, and the original dose is a sub 0. So we want to find out the t value when we have 90% or 0.9 of a sub 0. Okay. So in that case, we can, again, play this game where we do a substitution. I'm going to substitute 0.9 in for a, 0.9 a sub 0 in for a. So I have a sub 0 e to the ln of 1/2 over 36t. And let me make sure I've read the problem and interpreted the problem correctly before I get too carried away. It was 31 and 3 point something. Xanax is a tranquilizer used in short-term relief of symptoms of anxiety. Its half-life in the bloodstream is 36 hours. How long will it take for the Xanax to decay to 90% of the original dosage? Yeah, so we're good. All right, so now I can divide both sides by a sub 0 and solve it for t, right? Because I'll have an equation now in terms of one variable. So you just take the ln on both sides. You'll get ln of 1/2 all over 36t equals ln of 0.9. Multiply both sides by 36 over ln of 1/2. And then you'll get t equaling 36 ln of 0.9 all over the ln of 1/2. Okay? And then we put that into our calculator, and we get approximately 5.47 hours. Okay? So that stuff kind of stays in your bloodstream for a long time. Okay, so that's the big and the tall of it. There'll probably be a problem like number 31 on the test there. Yeah, so go in, just like I was saying at the beginning of my little spiel here. go through the video, watch me do number 15, then pause the video, go in the book, do number 16, do number 14. Try to do your problem like I do it. Okay. When it comes to the test, make sure you're reading the directions. So like on 29, do I need to show the asymptotes? Do I need to show the domain? Do I need to show the range? Okay. I guess you'll kind of have that fact memorized about the logarithms. Okay? So to find the domain of a logarithmic function, you need to set the insides of the logarithm greater than 0 and solve. You gotta know how all the logarithm rules work. You gotta know how to solve exponential equations. And for logs, remember, you always have to check your solutions. Okay? And then you may need to have this formula memorized. I don't remember if I put it on the test. Okay, so that's about it. Thank you for watching, and good luck on the next test. We'll see you next time.